morning, good afternoon, good evening, whatever the case may be. We are back and better than ever. There she goes again, indeed, and she being the beautiful subject of mathematics. Let's get to it, shall we? Today we are talking about double angle formulas. This is part one. We are continuing our trigonometric relationships and identities. So let's get right to the double angle formulas. There they are. These are the ones that we'll be using. There are some more listed here, but these are the ones that we will be using. This is from the textbook, and this is what is on your formula sheet. So we have sine 2 theta equals 2 sine theta cosine theta, and cosine 2 theta is equal to 3 different things, all of them useful depending upon the situation. Now in class we will talk about why they are true. We'll show you how they are true, and with experimentation and of course with proof. But I wanted to put in a derivation here, a proof of why sine 2 theta equals 2 sine theta cosine theta. That's right here. You can pause and take a look at it. And these all go together. Notice there's equation 1, equation 2, equation 3. Some of those are referred to on these proofs. Here are the cosine double angle identities. And we're using sine and cosine in this course. We might use tangent, but we'll see how that goes. But here are the formal proofs. And again, here they are as they appear in the textbook and on our formula sheet. So let's giddy up with a couple of examples. These angles make things easier for us when solving trigonometric equations, and as we get further into calculus, they become quite useful for us. And they're on our formula sheet for our reference. All right. So if we're given that sine alpha equals 3/5 and cosine alpha is equal to -4/5, find sine 2 alpha. Well, this is straight substitute and chug along. I'm not going to say that plug word. Ooh, I said it. All right, so we know that sine of 2 alpha is equal to, bam, 2 sine alpha cosine alpha. That's an S, cosine alpha, from right here. So this would just be equal to, I know that sine alpha is equal to 3/5, so that would be 2 times 3/5, and the cosine of alpha is -4/5. And if we clean that up, we get -624/5. Done. Done, 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 done. Now, don't get too excited here about the easiness of this, because we will be, this is really just getting you used to the double angle formulas. We'll be using them for substitution, again, to make things easier. Okay, cosine 2 alpha. Well, we have lots of choices here. We can use any of these because we have both sine and cosine. I'm going to use the first one. Cosine of 2 alpha is equal to cosine squared alpha minus sine squared alpha. So in this case, that would be -4/5 squared minus 3/5 squared. So that would be 16/25 minus 9/25. And if I count on my fingers, I can see that is equal to 7/25. All right. Another example. If sine alpha equals 5/13 between pi over 2 and pi, find the exact value of sine of 2 alpha. Okay, so let's just think about that on our unit circle, just so we have a reference here. So we go boom, boom, sorry, and here's pi over 2, and here is pi. So we got to find sine 2 alpha, and here sine 2 alpha or 2 theta is equal to 2 sine theta cosine theta. Well, I have sine, but I do not have cosine. So I have got to get sine. So I can do that using the Pythagorean identity, which says that cosine squared alpha plus sine squared alpha has to be equal to 1. So I can use that to solve for cosine. So cosine squared alpha plus sine of alpha is equal to 5/13. So that would be 5/13 squared is equal to 1. So cosine squared of alpha plus 25 over 169 is equal to, now I have a denominator of 169 here, so I'm going to change 1 to 169 over 169. And I subtract 25 over 169 from both sides, and I get cosine squared alpha is equal to 144 over 169. 169 minus 25 is 144. And so then cosine of alpha is equal to plus or minus the square root of 144 over 169, which is actually equal to plus or minus 12 over 13. So I know that cosine alpha is equal to plus or minus 12 over 13. Okay, but we have a restriction here. Yes, alpha is between pi over 2 and pi. And I have a positive 12 over 13 and a negative 12 over 13. Well, we know that cosine is positive in quadrant 1 and is negative in quadrant 2. So therefore, we throw out the positive one, and because of these restrictions here that we're between pi over 2 and pi, and cosine is negative, well, I know it must be that cosine alpha is equal to 12 over 13. Or I'm sorry, negative 12 over 13. So now we're in business, and we know that sine of 2 alpha is equal to 2 sine alpha, cosine alpha, boom chugga lugga lugga. So that's going to be equal to 2 times, we got 5 over 13 for sine, and for cosine we have negative 12 over 13. So that's going to be equal to, let's see, 2 times 5, so that's negative 120 over 169. All right, so that is it for part 1. I know you enjoyed it. I certainly did. And with that, I am out! Just